Okay, so here we are. Hopefully this is recording okay. So if we have two sets A and B, we want to know how to count them. So you have two sets A and B, and you would like to know what the size is of an element that's in one or the other, which is called the union. This is called the union of A and B. Okay? Well, the best way to do that is to draw A and B. Here's A, here's B, and break them into regions. So this is region 1, this is region 2, and this is region 3. Now region 1, I'm going to shade it so it only includes this. It doesn't include region 2. Now obviously A consists of region 1 plus region 2 as far as size goes. And okay, I'm not putting bars on this, I'm just writing size. And B is region 2 plus region 3. Okay, so now if you add A plus B, which is the size, you can do it as size if you want to. You could put size here if you wanted to. So we can make it size. If you add them together, basically I'm just going to write it this way: region 1 plus region 2 plus region 2 plus region 3. So you can see that if you add A and B together as two numbers, you're going to end up counting region 2 twice, and then region 3. Well, the actual answer is that if you take the union of A and B, that's going to be 1 plus 2 plus 3. So region 2 is really only counted once when you take the union. So you take the stuff in here, stuff in there, and stuff in there. There's 3 of them, the 3 regions. That's that. So in order to get the union of the two, and you add it by adding the size of each of these sets, you're going to have to subtract out region 2. Okay, so this is the same thing as saying that A plus B minus A intersect B. So it's a very useful formula for it. A plus B is 1 R2 R2 is 1 R3, so you got to take 1 R2 out of it, and so then you're going to end up with just region 1 plus region 2 plus region 3, because you subtracted out region 2 from it in here, which was in there twice. So you had this right here, and when you added them so A plus B, you add them together, you get 2 region 2. So if you subtract region 2 out of this, just down here, you're going to end up with just 1, 2, and 3. Okay, so that's the formula for A union B. Now the other thing you need to know is A union B union C. You need to know that one. Well, the formula for that is you take A, you take B, you take C, you subtract out all the intersections, okay? And then you have to add back in the triple. Add in once. Okay, so I'm going to show why that's true. And so here it is. I wrote it down here why it's true. I'll just go over it really quickly with you, what I wanted to do. So if you want to find the size of 3 sets, you add each one in individually, the size of each one individually. You subtract out all the doubles, and you add in the third. Why is that? So I divide the A, B, and C into 7 regions. There's 7 regions here. There's 1, 2, 3, which are these outer regions, 4, 5, and 6, which are sort of the inner regions, and 7 is the innermost region. And the size of the union is each of these regions taken once, because the whole thing consists of all the pieces of the pie here, and there's 7 pieces of the pie. But you notice that A is region 1, region 4, region 6, and region 7. So what I'm doing is region 1, region 4, region 6, region 7. B is region 2, region 4, region 5, region 7. So I've broken it all up in these little bits and pieces, and I'm adding them up to get A, B, and C. These are actual values for C. C would be 3, 5, 6, and 7. Okay? So if you add together A, B, and C, you're going to be adding up these 3 things. So you're going to get 1, 2, and 3 once. You're going to get 2 4s. You're going to get 2 5s. and you're going to get 2 6s, and you're going to get 3 R7s. That's the important part. Now, if you take the intersection of each one double intersections, A and B is 4 and 7. If you look at A and B, that's 4 and 7. A and C is 6 and 7. And B and C is 5 and 7, if you see that, okay? So if you take ABC minus AB minus AC minus BC, what you're going to end up getting, subtracting out, you're subtracting out 4, 7, 6, 7, and 5, 7 out of this thing here, because ABC is this, okay? So you're taking out 1 R4, taking out 1 R6, taking out 1 R5, so you're going to get 1, 2, 3, 4, 5, 6. And notice you're taking out R7 3 times, because each of these intersections contains R7. And over here, this sum contained R7 3 times. So you end up missing an R7 when you take this difference here. So ABC minus A intersect B minus A intersect C minus B intersect C is missing the region 7. So you have to add region 7 back in, which is A intersect B intersect C. And that then gives you your formula, A plus B plus C minus the double intersections plus the triple. And the triple only you add it in once, back in once. And that's the end of that.